In a previous lesson, I introduced how we will go about modeling the anatomy of a robot. And I started by explaining that just like human anatomy, where we have bones and joints, a robot also has a sort of an anatomy, right? So a robot has links, which are like the bones of the robot, and joints that connect these links together and define how the robot will move. And we also talked about how we're going to use URDF, a Unified Robot Description Format, to define this anatomy of the robot. And URDF is XML based, so you're going to code it, if you want to think of it as code, by typing XML. Before we actually go into URDF and XML and how to code this anatomy, let's talk about the different kind of joints that we will find. Okay, so a robot can have multiple types of joints, but the four most important ones that we're going to use to define the anatomy of our robot are a fixed joint, which is technically not a joint. It's more of a rigid connection between two links. Okay, so most of the anatomy of a robot is actually fixed joints to connect different parts of the robot. Like, for example, to connect a camera sensor to the base of the robot, or to connect a LiDAR to the base of the robot. Those are usually fixed joints. So they're not really joints, but we still call them that. Then we have the revolute joint. This is kind of like a standard hinge joint that rotates around a single axis, but it has defined upper and lower angle limits. Okay, so just like a human elbow, right? We can bend it and move it, but not all the way around. Okay, so it kind of like rotates, but within limits. This is a revolute joint. And then we have a continuous joint. This is like a revolute joint, but without any limit, so it can just spin continuously. And this is usually the kind of joints that we use for wheels. And then a prismatic joint is a joint that can move along an axis without rotating, like a piston. And it also has defined limits. Anyways, let's look at some of them, because it will make more sense before we look at some of them. And no, we're not going to look at URDF right now, because if I show you XML, you'll be like, ugh, what is this? So before I show you XML, I'm going to show you an actual robot. So let me run this code. This is ROS2. Don't worry about ROS2 for now. It's just a tool. We'll get there later. This is not a ROS2 course. This is RViz, and this is a robot defined using URDF. And I can link later to the tutorial where you can learn how to build this robot. It's a very popular tutorial from the ROS documentation. But what I want you to concentrate on right now is on the different joints, and then we're going to look at the URDF in the next lesson. So here we have this control here, this set of sliders, when we can actually change the values for some joints. So fixed joints, we cannot change them, but if I can show you some examples, so let me deactivate here the robot model. So some fixed joints will be like, let me bring it back actually, like the connection between this vertical piece of the robot and this horizontal one, which basically builds one of the legs of the robot. That's a static joint. So this here that connects the vertical leg to the horizontal part of it, this joint is fixed. It doesn't move. Okay. Each of these triads or coordinate systems represents a link, and this yellow line or vector with this pink tip represents the joint and connects or relates the two links together. Okay, so here's a fixed joint connecting two links. Now let's have a look at a continuous a continuous joint. So that's something that can be used to implement wheels. So if we look at this here, it says right front wheel joint. So if I move it, you see I make the wheel rotate. And it can go, it can rotate like 360 degrees, although the values here are provided in radians. So I can make it rotate 360 degrees as it should, because it's a wheel. Okay, so you see how the coordinate frame or the triad for the link representing the wheel is rotating. Okay, so the same is true for all of the wheels. They're all continuous. Now, a revolute will be, for example, the left gripper joint and the right gripper joint. Okay, so this can also rotate, but only within certain limits. So here, if you see, I'm opening the gripper joints. I open one of them, and I can open the other one. Okay, so it's rotating, but only within certain limits. Unlike the wheels, which are continuous joints, these revolute joints cannot rotate continuously, like in 360 degrees, or the corresponding value in radians. Okay, so these are revolute joints. And then the fourth type of joint is the prismatic, which is the one that moves along a certain axis without rotating, like a piston. So one example of that is the gripper extension. So here you see the gripper extension, it can extend or contract. Okay, so it goes like in, it goes out. This is the prismatic kind of joint. Okay. So again, as I said, if I deactivate the robot model, this is a TF tree. Don't worry about what that means. We're going to cover it later. But this tree basically shows all of the links represented by these coordinate systems or triads, and the joints connect the different links together, and are represented with these arrows. And as we already saw, some of these joints are so continuous. Some are like this one. Some are revolute, like the gripper extensions. Oh, sorry, not this one. Like this one. Some are revolute. Many are fixed; they won't move. And then some are prismatic, like the gripper extension. Okay, you can see here this arrow representing the joint. You can see how it produces that movement of contracting or extending the extension. And that's it. This is a quick introduction to what we will get from URDF, the output of URDF, without actually looking at URDF. I didn't want to show you the XML right away because it's going to be scary. So let's look at what the XML will produce first before we inspect the code. So see you in the next lesson.